Hello everyone. Welcome back to Dr. Lu's VCE Chemistry channel. Today, let's learn together about the 2019 VCE Chemistry examination. We will focus on questions related to electrolysis and rechargeable cells. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. This molten mixture contains aluminium, sodium, chloride, and fluoride ions. Aluminium and sodium ions are positive charge, so they can gain electrons but not lose electrons. The electrons are injected into cathodes. So, these two cations gain electrons on the cathode. So, B and D are eliminated. However, aluminium ions are the stronger electron acceptor than sodium ions. So, aluminium metal will be produced at the cathode but not sodium metal. So, A is eliminated. Chloride and fluoride ions are negative charges, so they can lose electrons but not gain electrons. The electrons are pumped out from the anode. And chloride ions lose electrons more easily than fluoride ions. So, C is correct. The baby shoes are connected to the negative terminal of the battery. The negative terminal of the battery injects the electrons, and copper ions gain these electrons. So, the shoe is coated with copper metal. Since this electrode receives electrons, it is the cathode. Ag ion has one positive charge, Cd and Pb 2 charges, and Al 3 charges. So, the largest mole of metal deposited is Ag if we give the same amount of charges. Although the atom mass of Pb is the heaviest, the mole of Ag is doubt Pb. So, the largest mass of metal deposit is Ag. The zinc cerium battery is rechargeable. One electrode is cerium ions, and another is zinc ions and zinc metal. The zinc electrode is lower than cerium ions. So, the zinc metal loses electrons and cerium ions gain electrons. Adding the half equations and deleting the electrons, we get the overall equations during discharge. During discharging, Se4+ gains electrons, and the oxidation number of Se decreases from +4 to +3. So, oxidizing agent is Se4+. The theoretical voltage is the difference between the voltages of the anode and cathode. Recharging is the reserve discharging. The positive electrode gains electrons during discharging. So, the positive electrode should lose electrons during recharging. The function of the membrane includes to prevent the oxidant and reductant from coming into direct contact, to prevent a spontaneous redox reaction occurring when the reductant and oxidant come into contact with each other to separate the two half cells, and to prevent the excessive release of thermal energy in the cell. The factors that limit the life of this cell include loss of the Zn electrode, side reactions at the electrodes, electrolysis of water during recharging, significant temperature change, and a buildup of gases around the electrode. Fuel cell, supply of reactants from outside the cell. Secondary cell, rechargeable/discharge reaction can be reversed. So, this cell is a hybrid of a fuel cell and a secondary cell. During the electrolysis of sodium chloride solution, the current efficiency is investigated. The aim is to investigate the effects of concentration of sodium chloride on the current efficiency. Hoffman is used to electrolysis water. Water is pure distilled water, or sodium chloride aqueous solution with 1.5 m or 4 m. The aim is to investigate the effects of concentration of sodium chloride on the current efficiency. So, the current efficiency or volume of gas collected is the dependent variable. Any one of the safety risks is okay. Hydrogen gas is flammable. Chloride gas is toxic. Sodium hydroxide is corrosive. Ensure no ignition sources are present. Limit exposure to chlorine by using a chemical, fume, hood or respirator, gas mask. The measure must consist of the answer provided in Part B1. Hoffman electrolysis apparatus is used here. The gas produced in anode or cathode is collected and their volume is measured. Results are precise. They are all within 0.3% of the mean values. The electrons are injected into the electrolyte by a negative electrode of power. So, water gains electrons to produce hydrogen gas and hydroxide ions at the negative electrode. First, calculate the amount of charge and the mole of electrons, then, a mole of hydrogen produced, and finally, the volume of hydrogen gas under SLC. Current efficiency is the amount of product produced, expressed as a percentage of the theoretical amount of product, calculated using Faraday's law. We substitute the volume of hydrogen produced and the theoretical amount of hydrogen, then, calculate the current efficiency. Both concentrations are under the same current. When the concentration is 1.5 m, the volume of gas produced at the negative electrode is 72 milliliters. When the concentration increases to 4 m, the 74.2 milliliters. So, the average volume of gas produced at the negative electrode increases as the concentration of sodium chloride increases. Or, the impact of concentration on current efficiency needs to be clarified at the positive electrode. Judgment can only be made at the negative electrode because of the increase in the ratio of chloride gas to oxygen gas at the positive electrode, depending on the concentration of chloride ions. State the change to improve the quality of this experiment. Use higher, or a greater range of, concentration of sodium chloride solution. The current experimental design has two different oxidation reactions occurring. Both oxygen and chlorine gas are produced at the anode. Higher concentrations of sodium chloride are more likely to produce chlorine gas. A greater range produces a more viable trend line. State two different aspects of the electrolysis experiment that the student should include in the discussion section of their scientific poster. Acceptable responses included: whether the data supports or refutes the hypothesis, comparison of expected to actual results, analysis of experimental design and errors, relating to earlier work. In electrolysis and rechargeable cells, 3 multiple-choice questions are worth 3 marks, and 2 short answer questions are worth 23 marks. The overall score for this section is 26 marks. With a total possible score of 120 points, the percentage for this section was 21.7% of the total score.
If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.